Morning. I was getting scared there for a second, but okay. So more on fractions and rational expressions. So I want to do a few numerical examples just to see whether we remember how to do these things with numerical fractions. So, for example, if you were asked to multiply two fractions, 6/5 and 15/4, we kind of went over that, but how would you do that? Well, but you're multiplying. Well, what should you do before you just multiply? Simplify, right? Because if you simplify before you multiply, your numbers become a lot smaller. 5 goes into 15 three times, and 6 and 4, can you reduce those? Right? So if you multiply now, you could multiply straight across. 3 times 3 is 9. 1 times 2 is 2. It is really important that you reduce before you multiply. Otherwise, your fraction becomes really large. And especially when you're dealing with algebraic fractions, it's going to get really large if you don't reduce first. So we need to get into this habit of reducing the fractions before we multiply. How do we divide fractions? How do we divide fractions? Anyone? What do I need to do in order to divide two fractions? Yeah, you do. So you're telling me if I put this question on the final, we're done, right? How do we divide fractions? No, I only need a common denominator when I add or subtract. Right, multiply by the reciprocal. Dividing by 16/24 is the same as multiplying by 21/16. So divisions are multiplication problems. You just change your divisor by taking the reciprocal. Then you can reduce this fraction. 4 goes into 16 4 times, 7 goes into 21 3 times, so we're down to 3/4. Right? You know that this is how you divide fractions, right? Multiplying by the reciprocal. What about this example? If I give you 19t over 20, so I'm throwing a variable in there, and I want us to divide it by t. What would that be? How do we go about this one? 1 over t. So when you're dividing by t, it's the same thing as multiplying by 1 over t. And then you see that there's a common factor of t. So I can cancel that. So the answer is 19 over 20. So again, we can reduce fractions through division, just like we've been doing so far. So in order for us to cross something out, it has to be a factor of top and the bottom, right? So when we're going to try to do some more complex algebraic fractions, we have to factor first in order for us to reduce. So basically, some examples on multiplication division. So here's a problem: 5x plus 5y over x minus y times x squared minus y squared over 10x. So again, remember, I can always cross out the common factors from the numerator and the denominator. But in order for me to see those common factors, I have to factor first, okay? Because I don't see any common factors yet. If we see them, you can start crossing out. But in this case, I have to start factoring. So I can pull out a 5 in the numerator. X minus y stays. And then x squared minus y squared can be broken down using the difference of squares over 10x. So just basic factoring, nothing fancy. Are there any common factors? Is there anything that I can cross out before I proceed with multiplication? No common factors between tops and the bottoms? You can think all the way across. This is your entire numerator, and this is your entire denominator now. There's anything we can cross out? Well, they're at the same level, x plus y, but x minus y, I can cross out. So you're crossing out from numerators and denominators. How about that 5 and a 10? Can I fix that? Because again, those are all products. It's 5 times x plus y times all that. And denominator is factors, so 5 and a 10 can be reduced. So we're left with x plus y times x plus y, x plus y squared over, which appears to be 2x. And there's nothing else to do. If you simplify before you multiply, then your final results are very small. And it's a lot easier to do it that way. Otherwise, if we were, multiplied before reducing, it would have been a big mess. And you can leave your answer like that. You don't need to expand that. So really, this whole multiplication, division of fractions is an exercise in factoring and just crossing out common factors. It's a lot easier than adding or subtracting. That thing was pretty hard. Well, this one. 7a cubed b to the power 5 over 3a minus 3b times 6b squared minus 12ab plus 6a squared all over 49, a to the 4th, and b to the 5th. So again, that's all big product. So right now, what this thing tells me is that 7 is a factor of the numerator, right? The way it's written, it's first numerator times the second numerator. So 7 is a factor of the numerator. At the same time, 49 is a factor of the denominator because it's a product. So can I reduce 7 and 49? Yeah. So right away, I can cross out 7, and 49 turns into 7. I can do the same thing with b's. B to the power 5 and b to the power 5 will cancel. And I can do the same thing with a's. A cubed and a to the 4th we'll leave one little a in the denominator. So right away we can reduce this ever so slightly. Again, I'm just crossing out common factors. Now, I can probably do more, so I should start factoring further. But at least I kind of made it a little smaller. So the first fraction has 1 in the numerator now. Everything kind of canceled out. In the denominator, I can pull out a 3, a minus b, times. Well, how do we go about factoring that second numerator? What's the first thing that I should do? Anyone? What do you do first when you're trying to factor something? Yeah, but before you do that, what is the first rule of factoring? The first thing you always look for? That's second. The first thing you always, when you're faced with the factoring thing, Gators common factors, we pull out a 6, because there's a 6 in there, right? There's a 6 all the way across that will make your factoring job a whole lot easier if you pull that 6 out. So I can cross 3 and a 6. 6 turns into 2. Now you can think about what kind of formula is that. So what kind of formula is that? Is that a formula, or is that something that we can deal with? B squared minus 2ab plus b squared? What is that? That's a perfect square trinomial. Can I reduce this further? Because you have a minus b and b minus a, right? So you should do some, you should flip one of them. And remember how we talked about if you flip inside the square, then nothing changes. So I can always go ahead and rewrite b minus a squared as a minus b squared over 7a. So a minus b cancels with one of the a minus b's. So the first fraction is gone entirely. All we have left is this. And that's our answer. So factor, reduce, and kind of simplify it as you go. You want your final step to be in the most simplified form, so your multiplication becomes very simple. Questions on this? Because of the square. Because there is a sign change, but then the square killed that sign change anyways. Because you had two options. You could have flipped here and changed the sign, or flip there and not worry about the sign because of the square. You would still get the same answer. Is that okay? What? Well, I don't know. It is, but it still involves a whole lot of factoring. So x cubed minus 1 over 8y divided by x squared plus x plus 1 over 16y squared. So as we discussed, when you divide two fractions, it's the same thing as multiplying by the reciprocal. So we're going to do that. And I also have to factor. So x cubed minus 1 is difference of cubes. You have this formula written somewhere, so it factors into x minus 1 plus x plus 1 over 8y times 16y squared over x squared plus x plus 1. Right, so we flipped the second fraction, turned division into multiplication, and now we can see a whole bunch of common factors. So we can definitely cross out the quadratic. That one's gone. And 8 goes into 16 twice. And y cancels with y squared. So now we just have to see what is left. Well, what is left here? So we have a 2, we have a y, we have x minus 1. Everything canceled out of the denominator, so it's over 1, so we're done. 2y times x minus 1. How's that? Okay, let's try this. A to the power 4 minus b to the power 4 over ab plus 2b minus 3a minus 6 divided by b minus a over a plus 2. So this one looks really messy. It doesn't feel like I can cross anything out. So we're going to start with factoring and see where that takes us. So, is there anything special about that first numerator? 2 even powers with a minus in between. What is that when you see 2 even powers with a minus? Difference of squares. So I can use difference of squares formula to break this down into a squared minus b squared, a squared plus b squared. Okay. Now the denominator has 4 terms with nothing in common. So how do we factor things like that have 4 terms with nothing in common? Grouping. So we'll look at the first 2 terms. AB, 2b, pull out a b, leaves us with a plus b. And the next 2 terms, pull out negative 3, leaves us with, well, yeah, a plus 2, that's right. That becomes a plus 2, and then it's another a plus 2. Times, I have to flip a plus 2 over b minus a. Now, I'm not done factoring that first denominator, so I cannot be crossing a plus 2 yet. A plus 2 is not really a factor yet. I have to pull it all the way out. Then I'll be able to cross it. So I have to keep factoring. A squared minus b squared in the numerator can be broken down further. A plus b, a minus b, and then a squared plus b squared. So that's that numerator factored over, pull a plus 2 out, leaves you with b minus 3 times a plus 2 over b minus a. So we've done nothing but factoring up to this point. So it's really all these problems are factoring exercises. Now the crossing common factors, that's the easy part. I can definitely cross out a plus 2 now, so that's gone. Now I have a minus b and b minus a. Can I cross those out? I mean, I should be able to. What do I need to do in order to cross them out? What? Yeah, I have to flip one. Now, what happens if I flip one? Switches the sign, right? So you can do the following. If you understand that concept that when you flip around the minus, the sign changes, you can just cross these two out and just put a negative somewhere. Because that's all it's going to do is going to create an extra negative. So you don't have to write that extra step and put that negative there. So after everything is finished, we're down to negative a plus b, a squared plus b squared, all over b minus 3. Is that okay? So that's fine. Sometimes you can take this negative and use it on that denominator if you don't like the negative up front. To flip the denominator, make it 3 minus b. So if you flip it, changes the sign again, so it kills that negative. But that's, either answer is okay. Again, so the whole idea is to factor and reduce, factor and reduce. Let's try this one. This one is a little smaller, but it introduces a new operation. So the order of operation tells me what? Do parentheses first. Well, there's nothing to do inside those parentheses. Then you do the exponent. So I have to take care of the exponent next. Now, by the rules of exponents, what do you do with exponents when you raise power to the power? What are you going to do with those two powers? Multiply. So you do the same thing with the one in the denominator. So 2 just multiplies both of those powers. Gives you a squared over x times x to the power of 4 over a to the power of 6. Because we multiplied exponents. So we have to follow the order of operation. Now we can just reduce, and the rest is pretty simple. X leaves us x cubed, and a squared with a to the 6th leaves a to the power of 4. So we're left with x cubed over a to the power of 4. Is that okay? So again, order of operation. Parentheses, well, parentheses were all set. Nothing going on inside those parentheses. And then you do the exponents. So if I make it a little messier, b to the power of 4 times b minus c squared over a to the power 6, c minus a, everything raised to the power 3. That's pretty. Still divided by something like that. B squared, B minus C over A cubed, A minus C, everything to the power 6. So this looks big and scary, but again, if we just stick with the order of operation, parentheses first, nothing goes on inside the parentheses. We actually like what's inside the parentheses. It's nice and factored. I don't want to mess with that when things are nice and factored. So the next step is to do the exponent. So you have to cube all of those little terms. Everything gets cubed inside the first parenthesis, and everything gets raised to the power 6 in the second parenthesis, each factor. So what we're coming down to is b to the power 12 times b minus c to the power 6 over a to the power 18, and then c minus a to the power 3, right? Just multiplying each power by 3, still divided by a to the power 12, b minus c to the power 6. Did I say, yeah, I meant b to the power 12 here. B to the power 12, and then a to the power 6, 18, and a minus c to the power 6. Is that right? Kind of got lost in there. Let me make it prettier. So this is b to the power 12 and a to the power 16. Not 16, 18. Here we go. So basically, I just multiplied each power by whatever power was on the outside. So division turns into multiplication, and you can already see a whole bunch of things we're going to start canceling. B to the 12th, b minus c to the power 6, over a to the power 18, c minus a cubed, times a to the power 18, a minus c to the power 6, over b to the power 12, b minus c to the power 6. So just flip the second fraction. So what can I cross out right away? What's going away? B to the 12, that's right. Yeah, the whole top. Yeah. What else? A's, 18th. So now a minus c, c minus a. So I should be able to tweak them, right? Now, so I either have to flip c minus a to make it a minus c, or I have to flip a minus c to make it c minus a. Which one is easier to flip? Why? Yeah, but so what will happen if I flip c minus a? What do I need to do? What happens when you flip around the negative? You pull out a negative. Now, what's going to happen when you cube that negative? Is it going to still be negative, or that negative sign will go away? Still going to be negative. Now, if you flip inside the power 6, that changes the sign. But then what's going to happen to the negative when you raise it to the even power? Will be positive. So again, every time you have an option to flip inside the even power, you can just flip inside the even power. You don't have to worry about that extra negative. You'll still get the right answer. It's just a little trickier. So if you have an even power, flip inside that. And that leaves you with c minus a to the 6th over c minus a cubed. And then you reduce that, just gives you c minus a to the power 3. If you flip inside the cubic, your answer will come out negative a minus c cubed. So it'll be the same thing, only flipped. So again, just make a note somewhere. If you have an option to flip around the even power, do that, because then you're allowed to just flip inside the even power. Makes it easier. Well, you subtract exponents, right? Yeah, when you divide, we subtract exponents. But again, everything was factored, so we just went ahead and we did the powers. So, just multiply everything by the outside power, and you cross everything out. So it looked bad, but I don't think it was all that bad, right? It's, you just play with exponents. Now this one is a little messier. X plus 2 over 3x squared minus 6x to the power 3 divided by x squared plus 4x plus 4 over x squared minus 4x plus 4, everything squared. So again, when you're faced with problems like that, your best friend is the order of operation. Just try to follow the order of operation. First thing is parentheses. So when you look inside the parentheses, the only thing that you can do there is to factor. And that's what you should do first. So first, we'll just factor inside the parentheses. So this is x plus 2 over, I can pull out 3x, and then leaves me with x minus 2, everything cubed, divided by, the numerator is the square of a sum, x plus 2 squared. Denominator is the square of a difference, x minus 2 squared, and everything still squared. So first step, do whatever you can do inside the parentheses, which in this case was to factor. So the next thing in order of operation is to do exponents. So that means we have to cube everything in the first parenthesis. So that gives me x plus 2 cubed over 3 cubed is 27, x cubed times x minus 2 cubed. Is that okay? Cubing 3 in there? And then I'm going to turn division into multiplication and make it times x minus 2 to the power 4 over x plus 2 to the power 4. So I flipped the second one and I multiplied all powers by 2. So then I can cross out x plus 2 cubed with one of those, x minus 2 cubed, I'm sorry, not with one, with 3 of those. Leaves us with one of each. So this is x minus 2 over 27x cubed times x plus 2. Questions on this one? So again, following the order of operation. Parentheses, so we factor in there, and then you do the exponents, and then you cancel out common factors. Is that okay? Okay, try this one. This is totally unrelated to what we've been doing, but I want you to see what you can do with this problem. So perform the following operation. And let's not use a calculator. Just use your knowledge of fractions. 1/2 minus 1/3 divided by 1/4 minus 1/6. Something like that. What'd you do? Uh-huh. And are you talking about the least common denominator? Okay, which is what? 6. So you have to multiply the first one by, I'm sorry. So 3 over 3, 2 over 2. What about the bottom one? Okay, 2 over 2. So that leaves us with 3 over 6 minus 2 over 6 over 3 over 12 minus 2 over 12, right? So then you subtract. In the numerator, you have 3 minus 2, which is 1, over 6. In the denominator, you have 3 minus 2, which is 1 over 12, right? And now what? Multiply by the reciprocal, because this is really 1/6 divided by 1/12. So it's 1/6 times 12, not 21. 12 over 1, and then you can reduce that, right? 6 goes into 12 twice, so 2. Right? Did you get 2 as well? Okay. Well, again, remember, that's just a big division. It's 1/6 divided by 1/12. That's what this means. 1/6 divided by 1/12, which is that. You should all be able to do that. I mean, it's just finding the, right? There's nothing fancy about that. Now, let me teach you a little trick. Because, again, as you might have seen the pattern, we always start with numerical examples, and then we're trying to extrapolate that to algebraic fractions. We're trying to keep things the same, same process. Now here, this is the correct process, but there is an easier way of doing this. So it's 1/2 minus 1/3 over 1/4 minus 1/6. Let me ask you this. If I ask you to find the least common denominator for all little fractions, you have 4 little fractions. One has a 2, one has a 3, one has a 4, and one has a 6. What is the least common denominator for all of them? 12. They all agree with that? If I ask you to find the LCD for all little denominators, the answer is 12. So let me ask you this. Is this a legal move? If I just multiply this fraction by 12 over 12, is that legal? So multiplying by 1. So what this means is that this first numerator is multiplied by 12, and the denominator is multiplied by 12. So I have to distribute 12 through. Now see what happens. If I multiply 12 by 1/2, what is 12 times 1/2? 6, right? Just 12 divided by 2. How about 12 times 1/3? What is that? 4. What about 12 times 1/4? 3. And what about 12 times 1/6? 2. So 6 minus 4 is 2. 3 minus 2 is 1. Right? That's a cute little trick. You've seen this trick before when we were solving equations that involved fractions, when you can just multiply both sides of the equation by the LCD to clear out all the fractions. That makes the problem a whole lot easier. This is the same idea. When you see a problem that has fractions within fractions, it's really hard to deal with that problem. But if you clear out all the little denominators by doing that LCD trick, it makes it a lot easier. That's a good trick. You'll see me using that maybe on Wednesday. I'll show you this now. Okay, good. So that was fun. Well, now you're gonna